Hello everyone and welcome to another video. Now what we have here is an Intel Core i9 14900K. This 24 core 32 thread CPU is one of the best you can buy, and if you intend to purchase one, well, you've likely budgeted for a top tier motherboard like this one for example, as well as a liquid cooler. Maybe a new case would be a good idea too. Yeah, I didn't think this one through. I didn't expect this to feature on the channel so soon, and I bet you didn't either. I probably would have put together a budget build in about 10 years time when I can find one for about 100 quid. It's likely I'll still do that, to be honest. Set a reminder in your phone for the 18th of October 2033. The thing with high-end processors is that we know that they are capable. We know that they can run every game that's out right now with really high frame rates, especially when paired with a top tier graphics card. On this channel though, well, I like to do things a bit differently, and unfortunately for the i9, it won't get the luxury of shaking hands with an RTX 4090 or 7900 XTX anytime soon. That's right, today we're seeing what the i9 can do with nothing but the integrated UHD 770 graphics. We did this a few years ago with a 10th gen i9, but back then we were limited to 10 cores, DDR4 and the UHD 630 iGPU. The results were, not great. Now there is some seriousness behind this of course. You might for example be building your dream setup piece by piece and saving up a little more for that aforementioned GPU. In the meantime you might fancy playing a bit of CS2 or Fortnite, perhaps Warzone. But can you? Well, let's see. In addition to the parts kindly provided by ASUS, I've purchased some 6400MHz DDR5, two 16GB sticks to be precise, which should help bring out the best of these results. So here we go. Now the thing is, you're going to get very similar results with the integrated graphics whether you buy an i9 14900K, i7 14700K or i5 14600K. All of these have UHD 770 graphics, which will be the limitation in every gaming scenario. The max frequency does vary slightly however, between 1.65 GHz max with the i9 down to 1.55 with the i5. The i7's onboard graphics come in at 1.6 GHz max. While we are using the fastest UHD 770 graphics then, I'm not sure how real world performance will actually differ, if at all. So let's start off with the sort of game you'd probably be able to expect to play with integrated UHD 770 graphics. Games like CS2 here, Counter-Strike 2 at 1080p, FSR performance mode is enabled with the lowest in-game settings, 67 FPS on average with a 1% low of 53 and a 0.1% low of 44. Before I benchmarked the games I did sort of decide between using 720p native or 1080p with FSR were available, and I basically went with the options that gave me the best performance. In most cases, if not all cases, that was actually using upscaling, setting 1080p first of all and then FSR. Not a bad start, and 60 FPS in CS2 is certainly playable, but you might find that other players with higher frame rates and higher refresh rate monitors will be quicker on the draw. But in terms of actual stutter and frame dips, things are pretty consistent. Cyberpunk 2077 is up next at 1080p with the FSR 2.1 Ultra Performance mode enabled. Again, we are using the lowest settings. We couldn't quite hit 30 FPS on average, which was a bit disappointing, but 28 was pretty close, and there were still some instances where we did break that 30 FPS barrier. As you can see by the 1.1% lows, again, performance was pretty consistent, even if the game was a bit of a blurry mess. Red Dead Redemption 2 up next with 66.7% resolution scale or 2/3 of 1080p. The lowest settings were enabled here, and I also enabled TAA medium simply to eliminate some of those horrible jagged edges. Despite this, we were still able to see at least 30 frames per second, 35 here to be exact, with a 1% low of 28 and a 0.1% low of 27, so no stutters or frame dips to speak of thanks to the pure power of the CPU. Fortnite is another ideal title for the UHD graphics here, and with the performance mode with the lowest settings and 100% 3D resolution scale, we were seeing 93 FPS. The percentile lows did suffer a little bit, coming in at 25 and 13 respectively, but this is generally what I do see in Fortnite across a range of different hardware. For Grand Theft Auto 5 up next at 1080p with the lowest settings and FXAA, we saw 62 FPS, 49 FPS was the 1% low, and 44 was the 0.1% low. So even in those busier areas, downtown Los Santos, the frame rate was holding pretty steady and the gameplay experience was one of consistency. At 1080p with the lowest settings, or normal settings as they're known in GTA 5, the game doesn't look too bad either, and I'd happily play like this using this chip. For Forza Horizon 5, this one features FSR 2.2. Again, it was set to ultra performance. As I said at the start, FSR generally gave us better performance than native lower resolution did, even if it was just by a couple of frames. And here with the lowest settings, we saw 40 FPS in this multi-competitor race, which is one of the more demanding scenarios. The percentile lows did suffer a little bit, and you may be able to pick up one or two of these stutters on screen. With a 1% low of 19 and a 0.1% low of 14, there were certainly a few issues, but not too bad overall. Finally then, we have Call of Duty Warzone at 1080p, albeit with a 37% render resolution. So yeah, this actually gave us better performance than enabling FSR 2 or FSR 1, and that result was 50 frames per second. We're also using the lowest settings once again, as I'm sure you would have guessed before even looking at this label on screen. 50 frames per second though really wasn't that bad if you can put up with the blurry and pixelated visuals. Of course, the 1% low was 35, the 0.1% low was 20, so not a terrible experience, at least not when actually playing, just a pretty horrific experience on your eyesight, if I do say so myself. These higher end chips aren't really what I'm used to reviewing. These are in no way my bread and butter, but it is always nice when one of these comes into the office, also known as my bedroom, because it gives us a chance to test out something different, even if I do end up just picking out the limitations rather than the capabilities as such with the integrated GPU here. Still, I think Intel's integrated graphics have come a long way over the years, and to see 60 FPS finally in games like GTA 5 now, as well as solid results in those lightweight titles like CSGO and Fortnite, well, it does make UHD 770 graphics a viable option. If you're waiting for that graphics card to arrive, you don't mind using lower settings, and you can put up with less than 120 FPS, for example, in those competitive esports games. Now, the general consensus, I think, with the 14900K is that it's not worth it over the previous 13900K, and some people have also recommended that you just save some money and get the 14700K i7 if you want to purchase a 14th generation chip. But, you know, this isn't what this review's about. I'll have more of my thoughts of this processor in a different video, I'm sure. I plan to use it in a really cheap motherboard as well, see how things fare, and hopefully you can join me for that one. Until then, leave a like if you enjoyed this, leave a dislike if you didn't, subscribe to the channel if you haven't done so already, and hopefully I'll see all of you in the next one.